Okay, good people. Let us look at two questions. Right. Question, the first question, they want us to derive the identity of tan A plus B. Now, before we do that, let's look at the quotient identities. We know that tan theta can be expressed as sine theta over cos theta. Having said that, we can then be able to express um, or to derive the identity of tan. Now, tan theta or rather tan open bracket A plus B equals to sine. We will express it in that quotient identity. It will be sine A plus sine B divided by cos A plus B. Okay. Then we will then apply the compound identities in expressing the right hand side. Now we are having sine A cos B plus, we are having plus, it will be plus here, plus sine B sine B multiplied by cos A. Okay, divide by cos A multiplied by cos B. We are having a plus, it will be minus. Then it will be minus sine A sine B. Okay, then from here we will then divide the numerator. We will then divide the numerator with cos A cos B, and we will as well divide the denominator with cos A multiplied by cos B. Now we will have something like this: sine A cos B divided by cos A cos B, plus, that is the numerator part of it that we are dealing with, by the way, plus sine B cos A divided by cos A cos B, divide by, we are now dealing with the denominator. We are having cos A. Let's use a different color for the denominator. Let's use the different color for the denominator. We are having uh, cos A cos B divide by uh, cos A cos B, minus, it will be minus sine A sine B divide by cos A cos B. Okay, let's wipe here on side so that we can use this side here. Okay, now we've managed to then do that. We can then cancel the like terms. The cos B and the cos B, they will cancel out. What is it that will be left with here? If they are canceling out, we'll be left with sine A over uh, cos A, isn't it? It will be plus. Then the cos A will cancel out cos A. Then we'll be left with sine B over cos B. Divide by, we come on the denominator part of it. Now under the denominator, cos A multiplied by cos B divide by cos A multiplied by cos B, it will give us 1. This will give us what? 1. Then we will have 1 minus, okay, minus. we know it will be minus, okay? Sine A, sine B, divide by cos A, cos B. Then we know that sine A over cos B, it is tan. It will be tan A. Plus sine B over cos B, it is what? It is tan B. We can express it as a tan. Divide by 1 minus. We know that sine A divided by cos B, it gives us what? Tan. Then we are having a tan A multiplied by tan B. We have then derived that identity. This is how we derive the identity of what? Of tan. Having said that, let's go then and do some application. Okay, we are given a equation here. They want us to prove that tan 90, tan open bracket 90 plus theta equals to minus cot theta. It's not a problem. It can be a problem. Okay, we know that tan theta, we can express it as sine theta divided by cos theta. Now, having said that, tan open bracket 90 degrees plus theta, it can be expressed as sine open bracket 90 plus theta divided by cos open bracket 90 plus theta. Okay, it can be expressed in that manner. Let's write our sign nicely so there. We are having sine. Okay, now it will be equals to, from there we will be applying the compound identity formulas. We are having sine 90 multiplied by cos theta. It's a plus, we'll have plus here. Then it will be sine theta multiplied by cos 90. Right. Divide by. Then we are having cos 90 multiplied by cos theta. It's a plus there, then we will have a minus. Then we will have sine 90 multiplied by sine theta. Okay, that's what we have. Now, what is it that we know about sine 90? We know that sine 90, it is 1 multiplied by cos theta. Plus, we know that then this side we will have what is cos 90? Cos 90 is 0. Then we will have plus sine theta multiplied by 0. Divide by. When we come on the numerator, we have already established that cos 90, it is 0. 0 multiplied by cos theta minus sine 90, it is what? It is 1 multiplied by sine theta. Okay, we've already established that. Then it will be equals to, now we will have cos theta, sine 90 multiplied by 0, it will be 0. Divide by 0 multiplied by cos, it will be 0. Then this side will be left with minus sine theta. Cos over sine, it gives us what? Cot. Then we are having negative cot theta. We have proved that this side equals to the right hand side. We have proved that the left hand side equals to the right hand side. Now, when coming to the proving, if you are given the question, please make note. You can use the right hand side to prove the left hand side. Vice versa, it is true. You can prove the left hand side that it is equals to the right hand side. I will send most probably relevant question regarding that which I just said. Nothing restricts us from proving Nothing restricts us from using the right hand side to prove the left hand side, and nothing restricts us from proving the left hand side equals to the right hand side. It will depend with the given equation which one we can work with to prove the other one. If the left hand side it enables us to prove the left hand side, then we will do so. We'll work with the right hand side. But if on the given equation we realize that the left hand side enables us to prove the right hand side, then we will work with what's given on the left hand side. Nothing restricts us, good people. Thank you, good people.